Hello everybody, welcome to another video. This is Hero, and today I just kind of wanted to talk about a project that I've started with my good friend Aro recently. So recently we've kind of gotten involved with doing some virtual reality stuff, and specifically we ran into a group that is learning American Sign Language and other forms of sign language all in virtual reality. But neither of us have a virtual reality system. So we decided that we were going to try and make our own, just sort of as a fun project, just because we could, and it'd be cheaper overall if we got things working, plus just be good experience to play with these sorts of things. So yeah, that's what we've been getting into. So today we kind of sat down and had our first big long conversation and brainstorming session and got some work done on it, and we actually made a good amount of progress to the point where I decided I was going to start actually documenting this. So I've decided that I'm going to be sort of doing my best to document our progress, keep track of things as we go, really do a lot of, well, I guess documentation, to say the word again, of our process, our progress, all of the above, kind of keep things going both through video logs, text logs, all the above. So this is the first text log of our DIY virtual reality full arm tracking system. So today when we got started, we spent a lot of time kind of discussing the layout of everything, specifically where all of the sensors will go on the body, because our goal is to, let's see, you know what, let me turn my camera on real quick so you guys can kind of see what I'm talking about as I go here. Ooh, it does not like that light. Let me turn the light off. There we go, that's a bit better. So you can see my hand here. So basically our goal is to be able to fully detect arm movements and full finger movements. So we want to be able to see all of these individual movements in virtual reality. So some of the hard parts of this are going to be the fact that we are going to need to be able to detect motions like the thumb swiveling under, which is very hard, especially when you're dealing with sign language, because you need to be able to do things like specific motions here, be able to have your thumb appear between fingers, so it needs to be rather precise. It needs to be able to swivel like this. Then on top of that, the fingers need to be able to turn, and they also need to be able to go spread apart and come together, as well as curling. The wrist needs to be able to have motion. The whole arm needs to be able to turn. Needs to be able to rotate like this. Needs to be able to bend. You can't see my shoulder. My shoulder's kind of moving right now too. So there's a lot of different methods of motion that we need to be focusing on. So to kind of get things going, this is our layout. We'll be updating this GitHub fairly regularly as well. This is a repository on Aro's account. I will have this linked in the description as well. There's not too much there, but as the project progresses, there'll be more and more showing up there. So in here you have the red and blue. It's pretty obviously marked. So let's see if I can kind of move the camera somewhere a bit different. Just kind of split the screen here. No, not the other monitor. Go like that. Okay, so you have the arm. You have my arm here, sort of matching that. So the red are the flex sensors. So those will be on this joint, the second joint on the finger. So we're calling the base of the finger is the first joint. This is the second. This one's the third. So this will be the second joint. This one will have a flex sensor, which will just detect pure angle of turn here. And then the blue ones are going to be the gyroscopes. So in this case, it'll be in between the first and the second joint right here. This will be able to check the angle in 3 different axes, hopefully. So you'll have the horizontal plane, which will let us turn, and it'll let you determine the angle of the finger as well if you're bending the finger. And it'll determine all of that and apply it based on the location of the wrist. So the way everything is going to be determined is it's going to measure the shoulder first, starting here, with a sensor gyroscope that will be strapped roughly here on the outside of the forearm. This will determine angle here as well as swiveling in this way. And then you'll have a flex sensor attached to the outside elbow here to determine the bend of the elbow. So all of our measurements and the positioning is going to be built on from those first two sensors. And then like this one, this wrist, the angle that your wrist is put at, let's see if I can get it good. Yeah, this will be determined by a gyroscope on the back of your palm here. This will determine, based on the positioning of your elbow and your rest of your arm, based from that, it'll be able to determine where the wrist needs to bend to be. And then from there, you'll have a gyroscope attached to the back of, between the first and second joint of each of your fingers. And this will determine the rotation of where the finger is in terms of spread and bend. And then just simple flex sensors on each of these knuckles because they only have one axis of movement. For these four fingers, the second flex sensor you see here, we're not sure if we're actually going to include that yet because there isn't really ever any movements where you will take your finger and bend it only at that first joint, nor is there ever a situation where you will bend only the middle joint. You will usually be curling that finger. The only situation we could think of kind of offhand would be when you're grabbing something. You tend to curl, that's like rather large and kind of fills up your hand. You tend to curl your fingers to grab things. But we aren't really going to be doing too much grabbing in terms of VR. We're really only going to be doing it for like sign specifically, so curling is the only thing you need. So what we can do is we can take the angle of that second joint and basically map the values to the third joint to just develop a uniform curl of the fingers, which would erase the need for the extra sensors on the third joints there. However, for the thumb, we'll have the same thing we're counting the first joint of the thumb at the base of the wrist because there's an axis of motion that happens here in terms of rotation. So we'll have a gyroscope here that will determine this rotation as well as somewhat the spread. And then we'll have a flex sensor here to determine the angle that this bends at. But then for this one, we are going to have a second, see if we can get a good, better angle at it for the camera. Second bend here, because a lot of times this needs to bend when this does not bend, or this bends when, or this bends and the thumb does not bend. So those two do need to be isolated from each other in terms of movement. So that's kind of an explanation of the sensors and where they are. So at this point, we got into a lot more technicalities. We realized that we were going to try and start putting pricing together, kind of figure things out, and we realized that for the flex sensors, pre-bought ones, the shortest you can get is probably about 2.5, 3 inches long, which is about this much space on a finger. And if you're trying to fit a single flex sensor, you really want it to be like under an inch probably to fill up that knuckle properly. So we started looking into how to create flex sensors on our own. And this is the part where I'm going to make the camera bigger again so that I can start showing our progress. So the first thing we learned was that you can create your own. We took some simple wires. Let's see, this one's going to be better to explain. So this has already been put together and taken apart again so that I could show the camera. But apologize for the low quality on the camera here. This is what you're looking at. This is just a simple wire. It's just cut on this end. There's nothing going on there. And then it's the masking tape that it's stuck to. And there's some remnants of paper that was stuck in there. Basically, there's two of these, and they get put together like this, trying to keep the wire on top of each other as best you can. It's a little hard to show that. But then in between them, it's all torn up because I had to take it off, but there is just a simple piece of paper that we put in between them to try and add, because keeps some separation and a little bit of stiffness, but it keeps the separation. You need to have the wires actually stack up on top of each other there. And then what happens is we literally just plugged those directly into two analog ports on the Arduino with a bit of struggle before we realized that we could do that. We took an Arduino Nano, two analog inputs, stuck this in pretty simply and started reading measurements from it. Unfortunately, there was a lot of inconsistencies with it. We weren't really sure what was going on. We had a lot of issues. There's some strange fluctuations happening. So eventually we kind of just like scrapped the big one, the proof of concept, because we're like, it's not working right. And we started working on the smaller one. And let's see if I can extract. So it's kind of just a jumble of all of my things I've been working on over here. Let me clean that up a little bit just to separate things out. This is the paper we were using, and over here is some of the aluminum foil that we were using. I'll explain that in just a moment. But then I don't need to have these out either. So at this point we realized that grabbed a measuring tape, decided that we wanted to fill up about 3/4 of an inch for the actual movement, because that was going to be the best option. So what I did is I took some aluminum foil, because it's a conductive material that's more flat than a wire. It'll actually bend much easier, of course, because of that. And cut a very small section. This one will be a better explanation for it. Cut a very small section and stuck it to tape. And then I took a piece of paper, cut it very carefully so that it would completely cover that aluminum foil, and then took my pencil and just drew all over both sides of it so that it's completely marked up on both sides and shaded pretty well. The camera doesn't pick up how dark the shading is, but it's pretty dark. And what this did is it covers in graphite, which is a conductive material. So from there, I took another piece of aluminum foil and stuck on another piece of tape that's the same size as the first one, so the paper will cover it. And from here, I took 2 wires, cut them, and stripped them. You can see one right here. And then basically attached those 2 parts of the aluminum foil, taped them on, and stuck them in place. And so now you have 2 halves. You take the paper, make sure the aluminum foil is completely covered, and then stick the 2 halves together. We end up with another flex sensor like this. So all of this has already been disassembled, so it's not really doing very well. But this is about an inch long in total, but if I cut it down to the actual size of the aluminum foil, it'd be about 3/4 of an inch. And then I actually took this and just took a piece of tape and strapped it to my finger, because we were getting decent readings from this one. And then I started just doing this, kind of holding it onto my finger, and it worked really well for something that was just kind of thrown together out of nowhere. So from this point on, we kind of realized that we had something going. So that's kind of the best way I can explain kind of what we're up to at this point. So moving forward, we kind of realized that, let me see if I can run through some other images here. So these are all just images. So then as for the code, this is our code that we were using. Turns out that, so this current system basically just works directly through analog, but it's pretty slow. So what we're trying to do is develop a new form of flex sensor that will just sort of work much quicker. So all of this is going to be mostly unnecessary in the final version, but this is what we're using right now. It just adds some control for margin of error in there. Just to kind of go through the code. You can see some of the assembly going on here. This is a better image. So the paper that I've drawn on with all the pencil is already covering up the aluminum on the other half. But this is what it looks like when it's cut in half and has the paper on there. And this is the other one, the first one I used that didn't really work too well, all put together. Let's see. This is when it's fully pulled apart. The paper ripped when I was pulling it apart, but you can see the 2 halves here, as well as the paper, and you can see the marks from where the paper was covering everything. And those 2 were just pressed against each other with the paper in between, and it worked wonderfully. But so kind of our plan now that we've started obtaining consistent readings and know that it's very possible to make our own versions of the flex sensors and keep them cheap but keep them small like we need them to be, we're we're probably going to attempt to make them either out of fabric or some form of plastic in the final version, so they're more durable and they actually work along the finger. And so moving forward, our next steps are pretty much going to be figuring out how to attach them properly, as well as developing proper ones. We also decided that the system is going to need to be calibrated for each user, because sometimes the pressure, depending on the size of the hand, changes the flex sensor a little bit, the readings on the flex sensor. So probably recalibrated for each user and possibly even recalibrated for each use. We're going to be getting a hold of at least 1 or 2 of the gyroscopes, because we don't actually have those yet, sometime in the next couple weeks probably, or hopefully, so that we can start testing with arm rotations, as well as kind of combining the measurements of the two to generate actual outputs for things. We're also going to need to eventually figure out how to make our own kind of headset for it, so we're probably going to use some form of smartphone application in order to create our own virtual reality portal for a smartphone. Yeah, that's just about where we're at right now, just kind of working through things. I'll be doing a lot of vlogs, kind of keeping up to date with things. I'll also hopefully start putting up videos during our actual sessions. Kind of today, as we were going, I realized that I wanted to start documenting things more, because we actually have something going now. And again, this is the first real time we've worked on anything today, so a lot of progress for a very short amount of time spent on it. And yeah, that about sums it up, but you can expect to hopefully see posts of us working on things live. I should probably edit them together and make it a little more concise, but you should be able to see us start working on things. Yeah, anyways, that's been the kind of introduction and part 1 of our adventure in making our own custom full tracking virtual reality system. So if you guys have any questions, leave it in the comments, send us a message. I'll have or at least have my Discord. I'll ask him if he's okay with me having his Discord in there, but I'll have my Discord in the description if anyone's interested, and as well as a link to the GitHub and a link to some resources we've been using and looking at. Like, actually, I'll go ahead and show this one because it's relevant. One of the ideas we're working towards is, this kind of inspired us here, is a flex sensor that's made entirely out of fabric. So this would be really awesome, since we're probably going to be developing some form of glove that just kind of sits on the hand here and goes up to like wrist section, at least up to here, so we can attach the gyro for the back of the hand, and then probably some form of like armband or something of the sort that goes up past about here and down to here, so that we can attach the flex sensor on the elbow and get the gyroscope on the arm. So we're going to be adapting this probably to our own use, using more of a flexible fabric, stretchy fabric, that sort of thing, and it'll be much smaller as well, especially if we're going to attach it to the finger, because this is probably 5-6 inches long, which is much too long for what we need. But this uses conductive fabric to achieve the same result we just did using aluminum foil and wires. So yeah, that's kind of how things are looking right now. Thanks for tuning in to the first edition of our adventures.